The problem I'm going to look at here is an example of, first of all, a word problem with a pretty challenging setup that's going to turn into a rational equation situation. And so, nice review of topics that come up in equation solving in Algebra 1 and Algebra 2, specifically the idea of using rational equations. So let's take a look at this here. Benji rode his bike 30 miles. If he increases his speed by 3 miles per hour, he would decrease his travel time by 20 minutes. I would like to find his original speed, okay? So he's going 30 miles. If he speeds up by 3 miles per hour, his overall trip is going to take 20 minutes less. And we've got to try to put all of this together, okay? So a couple of things here. This is going to revolve around the equation distance is equal to rate times time, or in a physics class, you probably talk about your rate specifically being a velocity. So distance is equal to velocity times time is the equation I'm going to use here. We know a couple of things. First of all, on the original trip, his distance is 30 miles, so we know that, okay? So 30 is going to be equal to his velocity times time. So, you know, for example, if he travels at 10 miles per hour for 3 hours, it would take him 30 miles, that sort of thing, okay? Then it says he increases his speed by 3 miles per hour, and that would decrease his travel time by 20 minutes, okay? Now, we have to be careful here. His original rate is in miles per hour, and this is talking about a travel time of 20 minutes. If we're going to be working in miles per hour, we need to be using all units of miles and hours. So 20 minutes is going to be the same thing. That's 20/60ths of an hour. That's 1/3 of an hour. And just to make sure that all of our units are consistent, I'm going to use that instead. So actually, I can write a second equation. It's implying that it's the same trip. So he's going to have the same distance. He's going to travel a total of 30 miles. Okay, he's increasing his velocity by 3 miles per hour. So instead of his velocity being v, it's going to be 3 greater than v. It's going to be v plus 3, okay? And it says it decreases his travel time by 1/3 of an hour. So his time is going to be 1/3 less than whatever the original t was, okay? And so technically I have a system of equations here. It's 2 equations, it's 2 variables. I should be able to solve. But I think what you're going to see as you try to solve this is there's a little bit more going on here than your typical system. So anyway, I need some space here. I'm going to take out this original problem and let's try to look at this equation and see what we can do with it here. I don't think elimination is going to work real well here. I don't think you're going to be able to like add and remove things and cancel variables. What I'm looking at here is, for example, I could solve for the t variable here. If I divide both sides by v, I would find out that t is equal to 30 over v, right? I can divide both sides by v. And so I'm going to replace the t in this equation with a 30 over v. So the equation that I'm going to be trying to solve here is that 30 is equal to v plus 3 times, I'm going to replace t with 30 over v, so that's going to be 30 over v minus 1/3, okay? And in fact, I'm going to take this entire equation away now. All right, so this is the equation I'm trying to solve, and I've got it down to just one variable. So, you know, on the surface, this seems like it should be pretty solvable, but there are going to be some challenges here. First of all, I don't love this 1/3 here. I'd kind of like to set this up so I've got whole number values. So I can multiply this term by 3, and that would knock out that denominator. However, if I've multiplied this side of the equation by 3, I also need to multiply this side of the equation by 3. So what I've got here is 90 is equal to v plus 3 times, I'm going to multiply this term by 3. So that would be 90 over v minus 1/3 times 3 is just 1. And that cleans things up just a little bit, okay? So now I'm going to go ahead and FOIL this out and see what happens. I've got 90 is equal to v times 90 over v will give me 90v over v, which is just going to be 90, okay? V times -1 is minus v, okay? 3 times 90 over v is going to be 270 over v, and then 3 times -1 is going to end up being -3, okay? And I think I've messed something up here. Where is it? I think I should have a v squared term. Let's see, v plus 3. Oh, no, I'm good for right now. All right, so a couple of things here I want to do. Number one, I want to get rid of this 90, because I can subtract 90 from both sides. Okay, so we'll get rid of that. I've got 0 is equal to, it's going to be negative v plus 270 over v minus 3 is what my equation is now. Okay, and here's the point where I have a couple of different routes I can go. This is going to create a rational equation. Okay, in other words, I have a variable that's a ratio, a variable that's a fraction here. Okay, and I've got a couple of different ways to be able to solve this. Okay, and a few things here. First of all, I think I'm going to multiply both sides of the equation by -1. That's not going to change this, right? It's still going to get 0. If I multiply this side of the equation by -1, I'm going to get v minus 270 over v plus 3, and I think that'll just give me a little cleaner equation moving forward. All right, so a couple of different possibilities here. One is, since I have fractions here, when you add fractions, you need to get a common denominator, okay? And of course, as a fraction, that's over 1, and that's over 1, and that's over 1. So if you notice here, my common denominator would be v, okay? So the first approach would be get a common denominator. I'm not going to do that with the 0 on this side. But to get a common denominator of v here, I would have to multiply the top and the bottom by the same value. So that would be v squared over v. This is already going to have that common denominator of v, so I'm just going to keep minus 270 over v. And then I can multiply the top and the bottom by v here. That's going to be plus 3v over v. Okay? If you think about adding fractions, if I add 1/6 and 3/6, I get 4/6. Okay, numerators add, the denominators don't. So we're going to get v squared. I'm going to write it as plus 3v minus 270 all over v here. It's going to be equal to 0. By the way, that's equal to 0 over v, right? If I wanted to have a common denominator here. And so the point here is, because the denominators are the same, those don't matter. Whatever v is, as long as it's a value that I'm allowed to have as a denominator of a fraction, which would be not 0, really just the numerators have to be equal. This value over here has to work out to equal 0, because the denominators are already the same. So really, I just want to solve the equation 0 equals v squared plus 3v minus 270. It's a quadratic. You could dump everything in the quadratic formula and solve it. It does factor. You'll have to fiddle around with it a little bit to make it factor. But you can do a v plus 18 and a v minus 15 to get it to factor. So you're going to get a negative 18, a positive 15. I know I've taken down the original problem, but remember that we're looking for a velocity. Okay, I think we're looking for a speed, and speed would always be positive. So, so this negative answer won't make sense in this problem. 15 here is a velocity. That would be 15 miles per hour. And you probably should check. If you remember, he was traveling a distance of 30 miles. So we know that distance is equal to velocity times time. And we can check this here. It was 30 miles is equal to a velocity of 15 miles per hour times the time. Means that he traveled for 2 hours at 15 miles per hour, and that was his original speed. Remember then that he increased his speed by 3 miles per hour, okay, so it went up to 18. And anyway, if you work backwards and solve this, you end up finding out that t would be 1 2/3. Okay, 1 2/3, that would be 1 hour and 40 minutes. If you remember, so he's traveling 18 miles per hour for 1 hour and 40 minutes. That's 20 minutes less than it took him when he was going at 15 miles per hour. So you can see this checks out. Okay. By the way, there is a second way to approach this, and a lot of you probably did it this way when you first saw the original equation I had. So I'm going to jump back to this version of the equation right here. 90 equals 90 minus v plus 270 over v minus 3. Again, a lot of you probably would subtract 90 from both sides and get 0 equals negative v plus 270 over v minus 3. You might multiply everything by -1. That wouldn't change the sign here. That would make that positive, make this negative, it'll make that positive. Some of you might have looked at this and just said, I don't want to have a variable in the denominator, okay? And so another approach here is just to multiply both sides of the equation by that common denominator. You can multiply this side by v, and of course when you multiply this side by v, it's just going to stay 0. And so what's going to happen here is v times v is v squared. V times negative 270 over v would be negative 270v over v, which is just going to simplify to negative 270. And then 3 times v gives you 3v. And you get the same thing that factored before. You'll get a v plus 18, and you'll get a v minus 15, and you get solutions of negative 18 and positive 15. So multiplying the numerator of both fractions by your common denominator to cancel your common denominator is also a good way to solve these problems. It's really just up to what you're most comfortable with.